Now next, I will go to the particular solution. I will say, okay, just a minute, this is a polynomial. From the table, I know polynomial to the rise to x to the power 3, it means x to the power 3 plus x to the power 2 plus x plus constant. So I wrote it here in this way. This is the particular y equal constant p plus constant qx plus constant x squared plus constant x to the power 3. I need to find the differentiate first derivative. I differentiate. Second derivative, I differentiate. Then I will come to substitute here, here, and here. What I got this equation. Okay, well, this is equal to the right hand side function. Now equate x, similar x to the right power on either side of the equation to find the constant. I came to equate them and I found the constant. I found first s, I substitute here to find r, I substitute s and r to find the q, and then I found p, as you can see here. Now, when I got this constant, I come back here to substitute this constant to find how it look like the particular solution. This is the particular solution. Okay. Now I have the homogeneous solution, I have the particulars, let's put them together. As you can see here, this is the final solution of the second order differential equation. This is the procedure for what we call it basic rule. Another example on basic rule, here I just change the numbers and change the function, which is cosine. Now I will start with the homogeneous or the complementary function. Here m squared, here plus m minus 6 equal 0. Then I open the bracket using cofactor and then factorization, and then I found the roots. Roots will be 2 and minus 3. They are real but different, so I write the homogeneous solution. Part of the solution I already quoted, which is the complementary solution. I come to the particular solution. From the table I got y equal constant cosine, you see here 2x plus constant sine 2x. Then I solve it. I find the differentiation, the first derivative and the second derivative. Then I come to substitute in the original function, as you can see here. Then I solve for the constants. I got the constant, as you can see here, c and d. I back to substitute c and d, and I have now the particular solution. Sorry. Now I can add them together. This is the homogeneous, this is the particular, and this is the end of the story. For the second rule, which is modification rule, we work as we said, which is the same procedure, complementary function. I wrote the auxiliary equation, I solve it, I found the roots, they are real different. I wrote here the final complementary solution. Now, before I go further, I need to compare my right hand side function with the homogeneous function, with the complementary function. If it's similar to some of these items, then I need to do modification. Just a minute. Here is constant and here is constant, so I need to do modification. What I will do, I will multiply, rather than here for c, you see here it's supposed to be yp from the table equal c, constant only, but because here we have constant, in the homogeneous we have constant, we will multiply by the lowest power x. Lowest power will be x to the power 1. This is lowest power. Then I do the same procedure. I differentiate first, second derivative, substitute here and here, and simplify. I got the constant, then back and substitute here. You got the particular solution. Now I have both. I have complementary, particular, put them together. Another example on modification rule. Here, this is my original equation. I will back to the particular. Let me solve the homogeneous or complementary. 3m squared plus 10m minus 8. I solve it by factorization. I go to roots, real different. I wrote here my answer. Okay. Now, before I go further, I come here. This is exponential function, but let me see. Forget about 7. I look to the function, which is exponential. Exponential minus 4x. And there is exponential minus 4x. What this tell me? This tell me I cannot assume the particular function y equals c exponential minus 4x directly, because it is available in the homogeneous solution, the complementary solution. I need to multiply by x. As you can see here, I multiplied by x because it needs modification. Now I make first derivative, second derivative, as we said before, follow the procedure, substitute and find the constant. Then this is the particular solution. I have complementary particular, adding them together will give me the final solution. Now, for some rule, sometime the function, the right hand side is two different functions. As example, sine and exponential. Okay. For homogeneous, we know how to do, what to do. Y squared plus 4m, I will write it m squared plus 4. I got the roots. It's found to be complex. Then alpha is not available, 0, so exponential 0 is 1. So I wrote here the complementary, let me say, solution. Okay, now this is the complementary solution. Before I go further, cosine 2x here, okay, and there is sine, sorry, 2x, and there is sine 2x in the function. Okay, what we need here, modification. Now have a look. For exponential, I have no problem. I wrote it directly, c exponential x. But because there is similarity here, this is sine 2x and this is sine 2x. I will not write sine 2x plus cosine 2x. No. I will multiply by x. I will say ax sine 2x plus bx sine 2 cosine 2x. This is the particular solution. Now I will go for the procedure later, but let me mention here something. Yes, this is some rule because I have here sum of two different functions. But at the same time, this function here, I need to use modification rule also. Anyway, I got here the yp, I differentiate first, second, and then solve for the constants. I go through the procedure, okay, as we discussed, and we will solve more exercises with time. Then I got the constant a, b, c. I back to the assumption, my assumption yp, and I solve for these constant. When I got the particular solution, I add it to the complementary. This is the complementary, and this is the particular, and this is the end of our story. This is the table again in different way, and let me take more example here. Have a look. Find yp. He asked me to find yp. Okay. Now he told me that yc, he solved it on my behalf, is this function. Let me see. This is exponential 2x and this is exponential 2x. I need modification. So I will write cx exponential 2x. I differentiate first, second, substitute here and here. Then I have this formula. Equate. You can see I will cancel at the end exponential from all the equation and solve. For c, I got c2. Then I back to substitute here. This is the particular solution. Now here are some exercises for different rules. I advise you to work on them. Have a nice day.